Okay, so this lesson we're going to continue looking at comparing two different populations to each other. Yesterday we looked at how to do that using a double box plot, so two box plots, one stacked on top of the other. Today we're going to look at a double dot plot. So you probably used a double dot plot before, or a dot plot, but we're going to use a double one. So it's really the same concept as what we talked about yesterday with a double box plot. So this would be two dot plots drawn on the same number line, one on top of the other. Once again, that's used to compare statistics of two different populations. And so that's what a double dot plot is. You want to get that down. If you want to see an example of a double dot plot, the second page with the examples, all the examples have double dot plots on those, and you can see what they are. So finish getting this down. If you need to pause the video, you can, and we'll move on. Okay, so a couple things about double dot plots before we move on. So on a dot plot, each dot represents when a number, that number is in the data set. And so, for example, if there are 4 dots on the number 84, that means 84 is listed 4 times in the data set. One thing that's nice about a dot plot is that the numbers are already in order from least to greatest. And so whenever we go and list that, if we have to find the median or even the IQR, as we'll do here in a second, you list that, it'll be 81, 82, 82, 83, 83, 384s, 285s, 286s, and 187. So we list those in order from least to greatest, and then it's easy to group those so we can find the median of that data set. Okay, so that's a dot plot. A double dot plot would just be another one stacked on top of this. So a couple of things when dealing with double dot plots. So to find, if we have to find the mean absolute deviation, so that's where we find the mean and then find the difference between each point. The only time that we would have to find the mean absolute deviation on a dot plot is if everything is symmetric. And what I mean by symmetric is that it's the same on one side and the other. Most of the time, we're going to have to find, actually probably all of the time, we're going to have to find the IQR instead. And so to find the IQR, if it says compare the variations, we would find the median. Okay, so we're basically going to split the numbers in half, one of the smallest, one of the largest. So if we had a data set, and I'll use this line to represent the data set, this would be the median because it's right in half. And then we're going to focus on both sections, the smaller section and the larger section. The way that we find the IQR is we're going to find the median of this half, the median of this half. The median of the bigger half of the data is Q3. The median of the smaller half of the data is Q1. And so we've got Q3 and Q1. And then remember, to find the IQR, you would subtract those two. So what we're going to do is find the median. This breaks it up into two halves. Find the median of the upper half, the lower half, and then subtract those two because that's Q3 and Q1. So thinking back to yesterday with the double box plot, that's what Q3 and Q1 were. It just visually showed us that on the box plot. For the double dot plot, we've got to do a little bit of work to find that. Okay, so a couple other things about double dot plots, kind of tells you which one to use. If both of the dot plots are symmetric, we're going to use the mean as our measure of center and the mean absolute deviation as our measure of variation. Now, symmetric means it is the same on both sides. So the exact same on both sides. So in other words, if it's symmetric, you could fold it up in half and it would look the same on one side as it is the other. Very rare is that going to happen. One of them might be symmetric, but it's almost never going to happen that both of them are symmetric. So what we're going to end up doing is using the median and the IQR. This is the one that we would use most often. Okay, so just go ahead and get used to finding the median as your measure of center and the IQR as your measure of variation. Okay, so let's look at our examples now. So this shows the number of new emails in each of Pedro's and Annika's inboxes for 16 days. So compare the centers and variations for the two populations. So what I need to do first is I actually need to write out what these are. And here's the number line that they show you. I need to write out what these are because that's going to tell me, make it easy for me to find the median and the IQR. So I'll do Pedro first. So for Pedro, I've got 32 twice. I've got 33, 34 twice, 35 3 times, and then 36 and 37 4 times each. Okay, and then for Annika, I'll do hers right here. I don't have a ton of room. I've got 33 times. I've got 31 3 times. Got 32 3 times. 33. 35 2 times. And then 36, 37, and 38. Okay, so I'm going to find the median. Okay, so I'm not going to cross off because I need to save these here in a second to find the IQR, but I do know there's 16 of them, so I'm going to have these two as the middle numbers, which means Pedro's center is going to be 35 plus 36 divided by 2. So in between those two would be 35.5. And then Annika's is going to be 32 and 32. And so it would be 32. Okay. So that's the median. Then I find the IQR. So the way that I find the IQR is I'm going to take the median, which is 35.5. Okay, that's the median. And I'm going to just focus on the smaller half. So there should be 8 numbers, and there are. Okay, then I find the median of this bottom half. So I can cross off now. Notice I've got 34 and 34. So that's going to be 34 as the median. Do the same thing here on the upper half. I've got 36 and 37. So this would be 36.5. So the two numbers I am subtracting is 36.5 minus 34. So the IQR for Pedro's would be 2.5. I mean the same thing for Annika's. So here's the median, which was in between these two numbers. So I find the median of the smaller half of the data, which is 31 and 31. So Q1 would be 31. Do the same thing for the upper half. I've got 35 and 35, so Q3 would be 35. So once I find that median, 35 minus 31, which would be 4. Okay, so the centers, the medians, I just write them out in order and find the median of those two, and that is 35.5 for Pedro, 32 for Annika. And then the IQR, I find the median of the upper half minus the median of the lower half. And that whenever you subtract, that difference is your IQR. So an inference I could draw about the two populations, I don't have enough room to write it, but One thing we could say is, on average, Pedro has more emails in his inbox than Annika, because notice that most of his dots are higher up on the number line than Annika's are. I could say that Annika's number of emails is more spread out than Pedro's because her IQR is larger. I could say the median of Pedro's is higher than Annika's. So there's a lot of different inferences we could draw about this. I would say on average, Pedro has more emails. That's probably the best one to use there. Okay, so let's do another example. I know that was a little different than what we're probably used to. So looking at the dot plots here that show the number of hours that each worked in 2 weeks, Jada's is symmetric. Notice that Jada's is the same on the left side as it is on the right side, but Angel's is not. So we're still going to use the median and the IQR for our center and variation. Okay, so we've got Jada and Angel. So the first thing that we've got to do is find the median. And so to do that, we need to write out these numbers. So Jada has 6, 2 7s, 4 8s, 2 9s, and a 10. Okay, and then Angel, do that right here. He's got a 5, a 7, 4 8s as well. 9, 10, and 2 11s. Okay, so once I write those out, let's go ahead and find the median. So if I cross off these, just make sure you don't lose track of what the numbers are. Well, Angel's or Jada's is going to be 8. That would be the separation between those. So if they're both 8, then obviously it's going to be 8. Angel will do the same thing. Cross these off till we get to the middle. And notice that Angel's has 2 8s in the middle. And so his is going to be 8 as well. Okay. So now let's find the IQR. So they both have the same median. Let's see if they're spread out. Okay, let's see if they're spread out as much as the other. So with Jada, we need to find the median of the bottom half and the top half. So cross these off. We're left with 7 right in the middle. And then do the same thing up here. We're left with 9. So remember, subtract those two. 9 minus 7 would give us 2. Do the same thing with Angel. Find the median of the lower half, which is 8. Median of the upper half, which is 10. So 10 minus 8, look at what we get. We get 2 as well. So their medians are the same and their IQRs are the same. So let's answer this last question. Who typically works a greater number of hours every week? So look at the dot plots because the median is the same, the IQR is the same. On average, whose numbers are higher up than the others? I would say Angel's are, because Angel's numbers are here. He's got 4 above 8. Jada just has 3 above 8. Angel works 11 hours twice. Jada doesn't work 11 hours at all. So I would say Angel would be my answer for that, because typically he works more hours than Jada. Okay. So I'll give you all a little bit of time. Pause the video and do that last one on your own. We'll come back and answer those 2 questions here in a second. Okay, so notice this question doesn't ask us to compare the centers and variations. It says which runner is more likely to run a faster race. When you look at this answer, this is where you want to find and compare the median. So for that one, you want to find and compare the median. And then more consistent, you want to compare the IQRs. Okay, so the median for Kareem is going to be 18. I'll write that here. Median for Kareem would be 18. Okay, and then the median for Martin, so let me check this real quick, is going to be 17. So the median for Martin would be 17. Okay, so which runner is more likely to run a faster race? I would say Kareem, because when comparing the medians, his median, his average, his measure of center is higher than Martin's. Then the question is which runner is more consistent in his race times? For that one, compare the IQRs, and I think it's going to be pretty easy to see. The Q3 for Kareem is going to be 19 minus 17, so I'll write that here. So we would have 19 minus 17, which is 2. For Martin, it would be 20 minus 15 and a half. I might be a little off, but it's either going to be 4 or 4.5. And that's obviously going to show us that Kareem's IQR is going to be higher. So Kareem is also more consistent. So whenever it's asking you to compare, this is one thing that's important. Actually use the statistics. Don't just look at, okay, which one is higher up. Some of Martin's seem like they're going to be higher up, but you want to actually find the statistics, find the medians. In that case, Kareem, even though you might not think it is, actually, I'm sorry. Hopefully you saw what I did. All right. One last little mistake that I need to correct. A faster race would mean they run a faster time, right? So if Martin runs a 17-minute median, then he's going to have a faster race. I was thinking who would run longer, but since you're talking about race times, think about that. Race times, you want a lower number. Okay, so Martin's number is going to be lower than Kareem, so he would run a faster race because his median is 1 minute faster than Kareem's. However, one thing I will say as I'm finishing out before I caught myself, the mistake I made, whenever you are comparing those two, actually use statistics. Find the median, find the IQR, use those. Don't just try to eyeball the dot plots and see what's best. Okay, so that is a double dot plot, and we've got a few practice problems to work on to get some practice with those. So you can go ahead and take care of that. Hopefully it made sense and everything was, you're able to get everything down.